Okay guys, in this video I will discuss about the different type of forces that are acting on the pile foundation for a pipe rack. Okay, so before starting the video, I would just like to thank all of my premium group member for joining this premium group. Okay, so let's start. So at the very first, if you are supposed to design any pipe rack, in that case you will encounter two type of frame. First one is your moment or portal frame, in this case this one, and second category of framing is a brace frame. Here you can see this is a brace frame. That's it. Only these two type of frame consist any type of pipe rack. Okay, and you know that in many cases the foundation, if this foundation or if these pipe racks are going to be built up in some Middle East area, in that case you may use some shallow foundation. Otherwise you normally provide, in American countries you normally provide the pile foundation, and that is a steel pile. Okay, just like this. So what are the forces you need to consider whenever you are supposed to design this steel pile foundation? Okay, so at the very first I would just like to discuss about the portal moment frame. Okay, so moment frame or the portal frame. So this is a typical portal frame or the moment connected frame, and it's a part of a pipe rack. Okay, so what are the forces acting? Well, definitely here you will have some large diameter pipe like this. So these are the pipes. Okay, so you will have some vertical load like this or like this. You can also consider an uniformly distributed load, and in addition to this you may have some lateral load acting like this because of wind or earthquake load. Clear? So due to this type of loading, what is the bending moment diagram? So if this is the portal frame, this is fixed, this is fixed, this is also fixed, and if these are the loading like this, you will have a bending moment diagram something like this. Okay, and like this. Similarly, on the right hand side also you will have a bending moment diagram like this. So here you can see, if we only consider the foundation part, okay, so here due to this vertical load you will have some compressive load acting on this foundation. So first, to design this pile, what you need to consider? First one is you need to consider the compressive load. Okay, second, you can see here that here you will have some bending moment. So this is the bending moment diagram. So in this zone, here you can see you will have a bending moment acting like this. So this is the bending moment diagram acting on this particular column. So at this level you will have some bending moment. So you need to design this particular pile to counter this bending moment. And normally what happened, that a bending moment is nothing but a push and a pull. Okay, so in that case, instead of providing a single pile, if you provide two pile, one pile will take the tensile force and another pile will take the compressive force due to this bending moment itself, and this vertical compressive load will be divided equally among these two piles. But if instead of having two piles you have only a single pile, in that case the whole compressive vertical reaction force is coming to this pile. Not only that, in addition to this vertical force, you will also have a bending moment acting like this. But in a single pile, you cannot counter this bending moment, because to counter any bending moment, you need at least two members, because one will carry the compressive force, another will carry the tensile force. So how this bending moment is going to be transferred? Well, in this case, the whole bending moment is actually being acting here like this. If this is the lateral load, okay, so the bending moment is actually acting as a whole throughout this structure. and it is converted into compressive force here and tensile force here. So if you have any lateral load acting like this here, you can see that this particular pile will take the compressive load and this particular pile will take the tensile load. Why? I think the reason is clear to you. So now it is clear to you to design the foundation of the portal frame. What are the forces you need to consider? Okay. Now come to the second part. That was our braceway. Okay. So what is the function of a braceway? Simply, you know that in a long direction we may have different type of lateral load. Maybe it is due to a pipe friction load. Okay. Or it may be due to anchorage load, or it may be simply due to wind load or earthquake load. So these lateral loads are simply being applied throughout this node. Then they travel this strut beam and come to this nodal point where the bracings are met. Okay. So if you consider this lateral load, it travels through this beam, then come to this joint, then travel this strut, come to this joint, then travel to this nodal point where these two bracings are meeting, and then from this nodal point it will travel to the foundation which is nearest. Okay. So in bracing, simply the lateral loads are being transferred to the foundation. Okay. So if we cut a particular braceway like this, okay, let's say this is a braceway. Okay, now let's say this is the lateral load. It simply travels through the strut up to this nodal point, then it travels to this foundation, okay, in the form of an axial load, right? So if you simply resolve this axial force, you will get a vertical component like this and a horizontal component like this. Okay. So in a braceway, to design this particular pile, what you need to do, you need to consider the vertical load that is coming due to this axial force. How? Simply, if you resolve this axial force, this inclined axial force, you will get a vertical component, and also you need to consider the horizontal force that is also coming due to this axial force through this bracing. Clear? So to design this pile in braceway, you need to consider first the vertical component as well as the horizontal component. Okay. So now if you consider this particular braced bay here, you can see this is the braced bay. So all the lateral load that are being applied here, they travel through this beam up to this nodal point. Then from here they travel up to this pile foundation. Again here you can see here is a single pile. So you need to consider the horizontal force acting here as well as the vertical component. Normally the steel pile have sufficient vertical load carrying capacity. Okay, but you need to consider or you need to check the horizontal shear capacity because the piles are hollow in nature. The steel piles are hollow in nature. That is why you need to check the horizontal shear force carrying capacity of the pile. And if it is not sufficient, let's say you have a large lateral load, in that case this horizontal component also become very high. In that case you may have to provide 2 or more number of piles to satisfy this horizontal force carrying criteria. Okay, so that's it.